Hello, this is Elizabeth Pluswick, and today we'll look at annual and effective interest rates in engineering economics problems. The example we'll start with is $100 today is worth how much in 3 years, given the investment will earn a 4% interest rate, simple interest, each year for 3 years. So we start with today is times 0. The balance of the investment is $100. At the end of year 1, that will have grown by 4%. So 4% interest rate times the balance of the investment is the amount of interest. That'll earn $4 in year 1, so we add that on to the initial investment. So at the end of year 1, we have $104. Year 2 then, same thing. We start off with $104 and add it. That amount now earns interest over the whole next year. So $104 earning 4% interest gives, at the end of the second year, we've earned another $4.16 of interest, gets added on to the balance just prior, and so at the end of 3 years we have $108.16 in the account. End of the third year, same thing happens. Take that balance at the end of year 2, it earns interest at the rate of 4%, so we end up with a balance at the end of 3 years of $112.49. We can call that the future value of the investment, and we started out with $100 present value. The interest rate, I, is 4%, and N, the time, is 3 years. Annual interest rate of 4% over 3 years, $100 initial investment will grow to $112.49 by the end of 3 years. So I've written that out here, that summary. $100 in present day dollars is equivalent to a future value of $112.49, given an interest rate of 4% annually for 3 years' time. All right, let's look at what happens then when the interest rate is not annual. So we need to translate an annual interest rate into an effective interest rate. So we have 3 letters that we'll be dealing with, variables. I stands for the effective interest rate per interest period. In the example we just did, interest rate was 4%. Interest period was 1 year at a time. The investment would earn a rate of 4%. Okay. We have another thing usually we use in engineering economics is a nominal or stated annual interest rate, and that'll be like per contract. What's the annual? Kind of the key word here is annual interest rate for the investment. We designate that by the letter R, and we want to take an R that we're given in the problem, if it's an annual rate, and turn it into an I, an effective interest rate per interest period, which might be the interest period. There might be more than one interest period in a year's time. We'll look at an example of that. And N is the number of interest periods, and that could be more than 1 per year. If interest is compounded semi-annually, you would have 2 interest periods per year. If interest is compounded quarterly, you would have 4 interest periods per year. And if interest is compounded daily, you would have 360 or 365 interest periods per year. Both of those numbers are used for daily compounding. Okay, so let's do an example here to translate R, the annual interest rate, to I, an effective interest rate. For N, 2 periods per year. In this case, interest is compounded twice a year, semi-annually. So we have 2 interest compounding periods per year. An annual or contract stated rate is 4% for the year. What does that mean per interest period? So we translate I equals R divided by N. R is 4% annual stated interest rate divided by 2 interest periods per year. So we end up with an I of 2%, which is the effective interest rate for 2 compounding periods per year. Right? So there I've written it out. I is 2% effective interest rate for 2 interest periods per year in this example. All right, let's look then at another example. Again, just a summary of the terms we're dealing with here. I, the effective interest rate, equals R, the annual interest rate, divided by the number of interest periods per year. So the example is if we have an annual interest rate on a CD, we put money into the bank, committed for a certain length of time. Here we're saying 5 years, and that 5-year investment will earn annual interest of 6% as the guaranteed rate, which is really high. And the interest will be compounded every quarter. So quarterly compounding means what? Every 3 months. 3 months equals 1 quarter. So in a year, we would have 4 interest periods per year, because 4 quarters in 1 year. Every quarter is 3 months. So in this case, it's a 5-year investment. We're committing our money to the bank to invest in a CD for 5 years. There's 4 quarters per year, so that's 20 interest periods. That would be our N in this situation, 20 interest periods over the 5 years. So let's do the conversion here. We're given an annual interest rate of 6%. Annual, so that's per 1 year, right? 4 interest periods for every 1 year. So we want to make sure these are on equal terms. 6% a year, 4 interest compounding periods, that's N, per year. So divide 0.06 divided by 4 is 1.5% is the effective interest rate per interest period, and there are 20 of those in the 5-year. In the next video, we'll do an example of how we use this to solve engineering economics problems with the interest tables.